Imagine a giant, hidden warmth distribution system crisscrossing our entire planet. What if I told you that beneath the surface of our vast oceans, there is a constant, slow-moving river of water that plays a crucial role in keeping our world habitable? Well, deep ocean currents spread heat through a remarkable, planet-wide system known as thermohaline circulation, often called the ocean's global conveyor belt. This slow but powerful movement acts like Earth's internal thermostat, redistributing warmth from the equator towards the poles and cold water back again. The key to this incredible process lies into fundamental factors: temperature and salinity, which together determine seawater density. At the Earth's poles, when ocean water gets extremely cold and sea ice forms, a fascinating chemical process occurs. The salt from the freezing water is expelled, making the remaining unfrozen water even saltier and therefore much denser. This super-dense, frigid water is too heavy to stay at the surface, so it sinks deep down to the ocean floor. Once this massive volume of cold, dense water reaches the bottom, it begins its incredibly slow and vast journey, flowing across the great ocean basins for thousands of miles. As it travels, this deep water gradually mixes with surrounding waters and eventually begins to warm and rise towards the surface in distant parts of the world, often in regions like the Indian or Pacific Oceans. This process, known as upwelling, is critical because it brings nutrient-rich water from the deep to the surface, fueling the growth of phytoplankton and supporting a huge array of marine life. The now warmed surface water then flows back towards the poles, where it cools again, becomes dense, and sinks, perpetuating this magnificent, continuous loop. This entire global circulation, from sinking to rising and back again, can take hundreds or even 1,000 years to complete just one full circuit. It truly is a slow dance, but one that profoundly impacts global climate patterns and sustains diverse marine ecosystems. Understanding this process helps us appreciate how interconnected our planet is. These currents are vital for regulating Earth's climate by transporting vast amounts of heat, preventing extreme temperatures in many coastal regions. Without this deep ocean circulation, many places that currently enjoy moderate climates would experience much harsher conditions. It also ensures that oxygen-rich water reaches the deep ocean, supporting diverse ecosystems that would otherwise struggle to survive. This also shows how changes at the surface, like freshwater input from melting glaciers, can impact deep ocean dynamics. A particularly significant component of this system is the Atlantic Meridional Overturning Circulation, which we often refer to as a MOC. This powerful current carries vast quantities of warm surface water from the tropical regions into the North Atlantic Ocean. The MOC is largely responsible for the relatively mild and temperate climate enjoyed by Western Europe, a stark contrast to other regions at similar latitudes. Consider also the fascinating deep-sea corals found in places like the Gulf of Mexico. These incredible organisms thrive in the abyssal plains, directly benefiting from the steady supply of nutrients and oxygen brought to them by these deep, cold currents. Even the smallest organisms, like phytoplankton, which from the very base of the marine food web, indirectly benefit from the nutrient-rich waters brought up from the deep by these larger circulation patterns, showcasing the intricate web of life sustained by these unseen forces. So the next time you think about the ocean, remember that for beneath the waves, an intricate, slow-motion heat engine is tirelessly working. This grand global circulation of deep ocean currents is a fundamental part of Earth's life support system, balancing temperatures, nourishing marine environments, and ultimately making our world a more stable and vibrant place for all life.